Hello once again. Here's another interesting project I put together a few years back. Thought I'd share, and mainly because it's full of PIC microprocessors, which I just love building with. It kind of all started when I found these programmable attenuator strips on eBay. They employ magnetic switching solenoids that switch in what they call tantalum resistive films on a sapphire substrate. That in itself is rather lovely, but unfortunately the first ones I got, all the sapphire substrates were missing. So I had to go looking for another one, which there seems to be lots of them out there. The other thing I found out when I got them was one was 12 volt, one was 24 volts. And the other thing was also that you have to reverse polarity the solenoid to switch them in and out. The one good thing, which would really play into the PIC part of it all, was there's a set of dry contacts that closes for indication that the section has been activated. So what I came up to use for switching into individual attenuator pads was these nice little solid-state relays, a TLP 222. They have two relays per section in a nice little 8-pin package. These relays were interfaced nicely into a larger PIC circuit, which would eventually activate what section was going to be required. Next was to develop some code to get the basic switching principles in place, and then eventually design a circuit board for it. This is the fun part I like the most, and getting all the parts put in place and getting it running. Then I had to build up the metalwork for the enclosure, built the walls out of 1/4-inch aluminum plate, and then the top and bottom cover is, I believe, 16th-inch aluminum sheet. So I had to build a remote panel to activate this thing, so I built another one of my corny-looking Star Trek remote control panels. I had built one of these before, so I still had the plans for it. I cut out some thin aluminum and very carefully MIG welded it all together. It was tricky. A little bit of sanding and grinding. It's amazing how well it will turn out, and then throw a coat of paint on it and voila. Looks like it was bought right off the shelf. Of course, there's another PIC circuit inside this thing with an LCD to tell you what's going on. This circuit talks to the main box by a serial cable. Hey, we'll power this thing up and show you some basic functions. Okay, when I power this thing up, it'll show you the usual preamble, when it was built and all that good stuff, version numbers. Next, it shows you that the data link between the control console and the main box is connected, and is asking you to enter what amount of dB attenuation you want. Hey, just to show how it's selected, I'll enter 20 dB. So you'll hear that click from the solenoids in the modules themselves, and the switch contacts close and tells the PIC to send me data telling me that 20 dB is now selected. Another feature I added into the code was a simple up and down button using the A/B buttons on the keypad. This increments the attenuation up by 1 dB or down by 1 dB depending on which button you push, instead of entering a complete number. So I had to set up a few things using a 8350 sweep generator. It's putting out a signal, and the HP 8756 analyzer is picking it up as a detector. I wanted to have the keypad entry being shown at the same time on a monitor, but it just, I couldn't get it close enough to show the resolution of the LCD, so I had to go separate. So I'll start off with entering 5 dB. And the scope shows 5 dB down. Then 10 dB. And attenuation is another 10 dB down. 15 dB. 20 dB attenuation. 30 dB. 40 dB attenuation. 45 dB. Then 50 dB. That's pretty well the dynamic range of the analyzer, so we'll go back to 10 dB. Now I'll use the A, B buttons for the 1 dB increments up and down. Okay, there's a small discrepancy of a few decimal points in dB, but it's close enough for this homemade project. It's a handy device to have. I use it every once in a while, but not that often. But sure was fun building it in another application for PIC processors. And that pretty well wraps it up for this project. There isn't too much else to show you. Hope you weren't too bored. Thanks for watching again.